We will continue from where we left off in our previous video. I will just quickly go through what we were doing. This was our question, and this figure represents everything that's given in the question. We wanted to find the time needed for this car to cover the distance from B to C. We called it T2. Using the speed distance time formula, we first found out the velocity from B to C, which is the distance BC over T2. For the part from A to B, we get the velocity V as distance AB over 6 seconds. Because the motion is uniform, the speed while travelling from A to B is also the same, which is V. After comparing these two equations, we got this one. If you remember, the data given to us is insufficient to find the values of AB and BC. But we can get the relation between them using the trigonometric ratios. Why are we looking for a relation between them? We're doing so because the relation will give us the ratio of BC to AB, and we can just substitute it here to get T2. It'll be 6 times this ratio. Using the alternate interior angles theorem, we found out the values of angles A and B as 30 degrees and 60 degrees respectively. Now let's just focus on the two triangles we have. A right triangle DCA, and there's a right triangle DCB here too. Which trigonometric ratios will we use here? Quite interesting. We want to find the relation between AB and BC. We will only need those trigonometric ratios which have either of these sides. Now AB is something we cannot involve here because it's a part of a triangle DAB, which is not a right triangle. So we can't really look for a trigonometric ratio involving AB. Instead, let's try to find the relation between AC and BC. And then we'll see if we can find the relation between AB and BC. Now both AC and BC are the adjacent sides of the two angles in question. And also notice that side DC is the side common to both the triangles. It is the side opposite to the two angles in question. So we use the trigonometric ratios which involves the opposite and the adjacent sides. Let's choose tan. It is opposite over adjacent. In triangle DCA, opposite of angle A is DC and its adjacent is AC. Also, angle A is 30 degrees. We get tan 30 as DC over AC. From this table, we find that tan 30 is 1 over root 3. We call this equation 1 and keep it as is. Now let's look at the trigonometric ratios of angle B in the right triangle DCB. As we are interested in the opposite and the adjacent sides, we use the tan ratio again. So tan 60 is DC over BC. Using this table, we get root 3 equal to DC over BC. We name this equation 2. From equation 1 and 2, we see that the side DC is common to both. Now our aim is to get rid of DC. How do we do that? We simply divide equation 1 by equation 2 to get this. And this gives us AC is equal to 3 times BC. I hope that you haven't forgotten the main aim of our problem, which is finding T2. Now we are very close to finding that. Remember that we wanted to find the relation between AB and BC. The above equation gives us the relation between AC and BC. We need to get AB into the picture. How do we do that? Notice that line AC is divided into two lines, AB and BC. It tells us that the length of AC equals length of AB plus the length of BC. Substituting this in the above equation and solving it further, we will get AB equal to 2BC. So finally we have that relation between AB and BC which we're looking for. But the problem isn't over yet. Ultimately, we want to find the time T2, which is the time taken by a car to travel from B to C. If you remember, this is the equation which we derived earlier. If we substitute 2 times BC in place of AB, we will get T2 as 3 seconds. So the time required for the car to travel from B to C is 3 seconds.